Okay, so now we're going to talk about different categories of parallelograms. So parallelograms can break down into two categories, rectangles and rhombuses, and then each rectangles and rhombuses each donate some characteristics and become squares. So rectangles, rhombuses, and squares are the three subcategories of parallelograms. Okay? Now, we're going to start with rectangles because that's what's flashing. Let me actually stop that from flashing because it's going to there we go. Okay. All right. So all these rectangles, rhombuses, and squares all have all the characteristics of a parallelogram. So opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. Okay, and it has some other characteristics. For a rectangle, the other two characteristics are that it has 4 right angles and the diagonals are congruent. Okay, so let's use that to solve equations. All right, we know since this is a rectangle, all these angles are right. So 5n minus 15 should be equal to 90. So 5n is equal to 105, and n is 21. Okay, just using the fact that a rectangle has 4 right angles. Okay, the next over here is they're talking about the diagonals, and the entire length of the diagonals of a rectangle are congruent. So not only do they bisect each other, they're also congruent. So to solve this, I would just say 3a is equal to 4a minus 14. Subtract 4a, and I get negative a is equal to negative 14. So a is 14. To check, I can plug it in. 3 times 14 is 42, and 4 times 14 is 56 minus 14, again, is 42. So those lengths are 42, right? If I'm going to do, if I want to prove that this quadrilateral here, ABCD, is a rectangle, the first thing I always have to do, no matter what kind of shape I'm proving, is prove it's a parallelogram. And the way you do that, the easiest way, is just prove that all the opposite sides are parallel. So I'm going to do the slope of AD and the slope of BC. Okay, and since it's a graph, I'm just going to count. AD goes down 1, 2, 3, and over 1, 2, 3. So its slope is negative 1. The slope of BC goes down 1, 2, 3, over 1, 2, 3. So its slope is negative 1. Okay? Then the slope of AB and the slope of DC. AB goes up 1, 2, 3, 4, and over 1, 2, 3, 4. So its slope is 1. And D goes up 1, 2, 3, 4, over 1, 2, 3, 4. So its slope is 1. So slope of AD is equal to the slope of BC, and the slope of AB is equal to the slope of DC. Therefore, AD is parallel to BC, and AB is parallel to DC. So now I've proven it's a parallelogram. Now I just have to prove what kind of parallelogram it is. So I'm going to prove it's a rectangle by proving diagonals are congruent. So I'm going to prove that AC is congruent to DB. Unfortunately, they're not horizontal and vertical, so I can't just count. I got to use the distance formula. So to figure out the length of AC, I do x is 1, 2, 3, negative 3 minus 3 squared and then up 1, 2, minus 1, 2, 3 squared. So negative 3 minus 3 is negative 6. Negative 6 squared is 36. 2 minus 1 is negative 1. Negative 1 squared is 1. So my distance of AC is the square root of 37. So AC is the square root of 37. All right, BD is 0 minus negative 1 squared plus 4, 5, 6 minus negative 1 squared. So that's 1 squared plus, did I count that right? 1, 2, 3, 4, 5, 6. Okay, so I accidentally said this was negative 3. It's negative 4 here. So this is actually 49 plus 1, so that's 50. So here I've got the square root of 50. Over here, 1 squared plus 7 squared is 1 plus 49, which is a square root of 50. So BD is the square root of 50 as well. All right, so that means AC is equal to BD. So quadrilateral ABCD is a rectangle because it's a parallelogram and diagonals are congruent. Okay? All right, so that's rectangles. Rhombuses, or rhombi, again, it's got all the characteristics of a parallelogram, opposite angles equal, all that stuff. A rhombus also has 4 congruent sides. The diagonals are perpendicular, so they bisect each other and they're perpendicular. And the diagonals bisect their opposite angles. Okay, so all the diagonals are perpendicular or are angle bisectors. All right, so we can solve equations. We can say it's a rhombus, so opposite sides are equal. Or actually, all sides are equal. So 9x minus 11 is equal to 4x minus 7. So 5x is equal to 4. So x is 4/5. I'm going to solve for x. All right? And then diagonals are perpendicular. So if this angle is 6a plus 18 is this angle here, it's a right angle. So to solve it, I would just set 6a plus 18 equal to 90. So 6a is equal to 72, and a is equal to 12. All right? Take a minute and go ahead and work this on a separate paper and turn it in tomorrow. So take a minute and work this problem right here and then get ready to turn it in. All right, and our last one are squares. And squares are unique because if rectangles or rhombuses got together and had a baby, they would have a square. They have the characteristics of a rhombus and the characteristics of a rectangle. So it's got all the characteristics of a parallelogram, okay? It's got the characteristics of rhombuses and rectangles. So it's got 4 congruent sides and 4 right angles. So it's got the rhombus and the rectangle. Diagonals are perpendicular. That's the rhombus. Diagonals bisect opposite angles, a rhombus. And diagonals are congruent. That's a rectangle. So all 4 of those are all the characteristics of the rectangle, all the characteristics of the rhombuses are contained in the square. All right? So if I want to prove that the diagonals um, oops, if I want to prove that this is a square by proving that the diagonals are perpendicular bisectors, because if you think about it, if the diagonals are perpendicular and they bisect each other because they're a parallelogram, then that makes them perpendicular bisectors. All right, so the first thing, again, every time I'm going to prove that it's a parallelogram. So I'm going to do the slope of BC and the slope of AD, which is up 1, 2, 3, 4 over 1, 2, 3, 4. So the slope is 1. From AD, it's over up 1, 2, 3, 4 over 1, 2, 3, 4. So it's 1. Okay, then the slope of CD and the slope of AB. Okay, down 1, 2, 3, 4 over 1, 2, 3, 4. So it's negative 1. And 1, 2, 3, 4, 1, 2, 3, 4. Negative 1 as well. Okay, so the slope of BC is equal to the slope of AD, and the slope of CD is equal to the slope of AB. Therefore, BC is parallel to AD, and CD is parallel to AB. Okay? So ABCD is a parallelogram. Okay, if it's a parallelogram, then opposite angles are, diagonals bisect each other, and but to prove that they're perpendicular bisectors of each other, I got to prove that first that they're perpendicular. So I find the slope of AC. Okay, one more slope, and it's vertical. Yay! So I don't have to do any calculating. That means that the slope of AC is undefined. And the slope of BD is horizontal. Yay! So that I don't have to do any calculating there. The slope is 0. So the slope of AC and the slope of BD are opposite reciprocals. Therefore, AC is perpendicular to BD. Okay? And if AC is perpendicular to BC, then I can also find out if they're a bisector, because remember I'm trying to make sure that it's a square, so it has to not only be equal, but it also has to, or it not only has to be perpendicular, but the diagonals have to be equal. So I'm going to prove that BD, the length of BD, which is, I can count because it's horizontal, 1, 2, 3, 4, 5, 6, 7, 8, is 8, and the length of AC is 1, 2, 3, 4, 5, 6, 7, 8. Okay? And I can prove, I think up here it asks to prove it's a perpendicular bisector as well. So if it's a perpendicular bisector, this is 1, 2, 3, 4, 1, 2, 3, 4. So they bisect each other. To prove that they're equal, then BD is equal to AC. So therefore, quadrilateral ABCD is a square. Okay? Running out of room here. Okay. All right. You know what? Why don't you try this one too? write the proof for this one and turn it in with that other problem I asked you to do. So let me move it down a little bit, and I think that's enough statements. I think we're good for that one. All right, I'll move this over. Okay, so take a look at it, and I will see you tomorrow. Oh, your work's in the book, so bring your book.